Alright, this video is about the Doppler effect. Every single one of you have heard this effect at some point in time, especially if like an ambulance or a fire truck or a police car or something has its sirens on and it's driving by you. You hear a change in the frequency or the pitch of the sound. Okay. And I've got a couple pictures up there, and these are also in your book. But if you have a fire truck and it's at rest, and it emits its sound if it has a siren on, if it's at rest and two people on either side are also at rest, what you get is you get the same exact frequency. Why? Well, because it's traveling the same distance in the same amount of time on either side. However, if the fire truck was moving towards one observer and away from another one, the wave fronts that the person where the fire truck is moving towards would start to pile up on each other. They get closer and closer together. If that's the case, if each one of those wave fronts hits you more frequently, you get a higher frequency wavelength. So when something's coming at you, you hear a higher pitch than when it's moving away from you. When it moves away from you, those particular wave fronts get stretched out. Therefore, they are less frequent. You get a lower frequency. Okay, this is what is called the Doppler effect. Okay, getting a different frequency based on the motion of either the observer or the source. Okay, now there are some derivations of these equations in your Giancoli book. There's also some stuff in the IB book. I'm not going to go through all the derivations, but you should make yourself aware of the following equations. For those who are in AP, you should make yourself aware of these. These are the ones that tend to show up for AP. So there are four different circumstances: source moving towards a stationary observer, and then source moving away from a stationary observer. Okay, you should make yourself aware of those. And then there's also one where it's observer moving towards a stationary source and observer moving away from a stationary source. So yes, there are different equations, whether or not the source is moving or the observer is moving. Okay, for IB, they split them into either the source moving or the observer moving. So they've narrowed it down to just two equations. What you have to do then is understand, do I have to add or subtract? Okay, well, if you're going to get a perceived frequency, okay, if this is the velocity of something and we've got the velocity plus or minus the velocity of the source, okay, if we add on the bottom, okay, then we reduce this number, we get a smaller frequency. Okay, smaller frequency or lower frequency, so that would have to be when it moves away. We'd subtract if we're moving towards. Okay, over here, okay, make sure again that you understand the plus and minus. Now you've got the velocity plus the velocity of the observer or minus the velocity observer. Okay, again, if we're going to get the perceived velocity, if we're going to get a bigger one here, we're going to add the velocity of the observer. That would mean the observer is moving towards that particular object. If we were subtracting them, they'd be moving away. Okay, so make yourself familiar with these particular equations. IB, these are actually in your packet. AP, these are not. Okay.